Perovskite solar cells, one of the hottest solar technologies since the debut of their first use in research back in 2009, have just gotten a significant step closer to redefining how we think about not just solar power technology but also renewable energy in general. In case you didn't know, silicon-based solar cells have dominated the renewable energy market since their introduction in 1954. And although they are long-lasting, they are also costly compared to new materials. This has led many consumers to consider investing in better, longer-lasting, and cheaper components over the last 50 years. However, silicon is still a globally used technique today, as it's also very efficient with current efficiency standards, and is considered one of the most common methods for photovoltaic technology. Perovskite solar cell vs silicon-based cell. Perovskites are a special kind of solar cell made of organic materials, and have paved the way for high efficiency. These low-cost solar cells are easily accessible because they can be manufactured at room temperature. This is especially beneficial for industrial solar power plants, because less energy will be required to produce them. Of course, silicon, crystalline silicon, is currently the most popular material for solar panels. It absorbs sunlight relatively well, and can readily be processed and turned into power-generating devices. However, we already know that silicon solar cells are not entirely transparent and also tend to lose their efficiency over time. This is why newer technologies like organic photovoltaics, OPV, are gaining traction. They are cheaper and more flexible solutions that could integrate into windows all around us seamlessly, which would, in turn, boost energy efficiency. A new method. Remarkably, the new device's estimated lifetime is a 5-fold increase over the previous record, established by a lower efficiency perovskite solar cell in 2017. According to the researchers, however, their accelerated aging technique might be more significant than their new device. Improvements in long-term testing methods have unfortunately not been implemented until recently due to the fragility of perovskites. However, as they improve with time, finding a way to test different design architectures, making any changes at an early stage, and making these tests more sophisticated will undoubtedly become increasingly important. We have a good team today, but there will be other teams who won't share the same weaknesses that we do and might even outperform us with time. Lin Lu, the Theodora D. 78, and William H. Walton 374 professor in engineering who led the study, said in a press release. It's our duty as athletes to make sure we never let ourselves ever settle for second best. The record-setting new device. The new aging method allowed testers to see the effects of hot air and other conditions on cell phones by blasting them with heat. Researchers chose several hot days and conducted tests under 4 temperatures ranging from a regular summer day's baseline temperature of 75 degrees Fahrenheit, 24 degrees Celsius, to an extreme of 230 degrees Fahrenheit x 110 degrees Celsius. Therefore, they concluded that their nanophotonic device will consume 80% of its peak efficiency for a minimum of 30 years when exposed to continuous, average temperatures of 95 degrees Fahrenheit. This is the same as being tested in Princeton, New Jersey's heat, which would be quite a feat. Joseph Barry, a senior fellow at the National Renewable Energy Laboratory, who was not involved in the study, said, "This paper is likely going to be a prototype for anyone looking to analyze performance at the intersection of efficiency and stability." The Renewable Energy Lab used accelerated testing methods to extrapolate these conclusions from prototypes intended for use in field testing if found successful. Perovskite solar cells, one of the hottest solar technologies since the debut of their first use in research back in 2009, have just gotten a significant step closer to redefining how we think about not just solar power technology but also renewable energy in general.